In recent years, military forces around the world have seen a dramatic shift in how unmanned aerial systems, particularly first-person view drones, are utilized in combat. Originally designed for civilian racing, these small, nimble drones have evolved into potent weapons on the battlefield, owing much of their effectiveness to advances in artificial intelligence. This essay explores how AI has made today's FPV drones possible, the current applications of these drones in military operations, and how AI is poised to further enhance this technology in the near future. The evolution of FPV drones and AI integration. FPV drones, initially intended for recreational use, are characterized by their high speed, agility, and relatively low cost. These drones are operated using a live video feed that gives the pilot a first-person view of the drone's surroundings. The transformation of these civilian drones into effective military tools is a direct result of technological advancements in AI. AI-enhanced flight control and navigation. AI has revolutionized FPV drone technology by enabling more sophisticated flight control and navigation systems. Machine learning algorithms have been developed to enhance the drone's ability to navigate complex environments. These algorithms allow the drone to process data from its sensors in real time, making quick adjustments to its flight path to avoid obstacles and maintain stable flight. This capability is crucial in combat scenarios where the drone must maneuver through challenging environments while maintaining precision. Target detection and identification. AI algorithms have also been integrated into FPV drones to improve target detection and identification. Computer vision techniques enable the drone to analyze video feeds and identify potential targets based on predefined criteria. For instance, an FPV drone equipped with AI can differentiate between various types of vehicles or structures, selecting the most vulnerable parts of a target, such as an open hatch or engine compartment, to maximize the impact of its payload. Autonomous mission planning. AI has enabled the development of autonomous mission planning systems for FPV drones. These systems use AI to plan and execute complex missions, including target selection and navigation. The drone's AI can analyze reconnaissance data to determine the optimal approach to a target, taking into account factors such as distance, speed, and potential threats. This level of autonomy reduces the cognitive load on human operators and allows for more efficient and precise operations. Current applications in military operations. The integration of AI into FPV drones has significantly enhanced their effectiveness in modern warfare. These drones are increasingly used for tactical operations due to their ability to carry out precise strikes with minimal risk to personnel. Tactical strikes. FPV drones are frequently employed for tactical strikes against high-value targets. They are often equipped with explosives and used to target enemy tanks, artillery positions, or other critical assets. The AI-enhanced targeting capabilities of these drones allow them to pinpoint weak spots in enemy defenses and deliver a devastating impact. For example, an FPV drone might be directed to fly directly into the engine compartment of a tank, causing significant damage or even destruction. Reconnaissance and surveillance. In addition to their role in direct attacks, FPV drones are also used for reconnaissance and surveillance missions. They can be deployed to gather real-time intelligence on enemy positions, movements, and fortifications. The AI systems integrated into these drones enable them to analyze the gathered data and provide actionable insights to military commanders. This information is crucial for planning subsequent operations and making informed strategic decisions. Psychological warfare. FPV drones also serve as tools of psychological warfare. Their ability to conduct precision strikes and surveillance can instill fear and uncertainty among enemy forces. The mere presence of these drones in a combat zone can have a demoralizing effect on adversaries, as they know that their positions are being constantly monitored and targeted. Future developments and AI's role in enhancing FPV drones. The future of FPV drones is intrinsically linked to advancements in AI technology. Several emerging trends and technologies are expected to further enhance the capabilities of these drones in the coming years. Improved AI algorithms. Future FPV drones will benefit from continued improvements in AI algorithms. Advances in machine learning and computer vision will enable drones to perform even more complex tasks, such as advanced target recognition and classification. Enhanced algorithms will also improve the drone's ability to operate in dynamic and unpredictable environments, increasing its effectiveness in diverse combat scenarios. Swarm technology. One of the most exciting developments on the horizon is the integration of swarm technology into FPV drones. Swarm technology involves the coordination of multiple drones operating as a cohesive unit. AI will play a crucial role in managing swarm behavior, allowing drones to communicate, collaborate, and execute coordinated attacks. This capability will significantly enhance the tactical flexibility and impact of FPV drones, enabling them to overwhelm enemy defenses and achieve strategic objectives. Enhanced autonomy. Future FPV drones are expected to exhibit even greater levels of autonomy. Advances in AI will enable drones to perform complex missions with minimal human intervention. For example, autonomous drones may be able to independently conduct reconnaissance, identify targets, and execute precision strikes based on real-time data and analysis. This increased autonomy will reduce the reliance on human operators and enhance the overall efficiency of drone operations. Integration with other technologies. AI will also facilitate the integration of FPV drones with other emerging technologies. For instance, drones may be equipped with advanced sensors such as thermal imaging or radar to improve their ability to detect and engage targets in various conditions. Additionally, AI-powered drones could be integrated with other UAS and manned systems to create a more comprehensive and effective combat network. Ethical and strategic considerations. As AI continues to advance, it is essential to address the ethical and strategic implications of using FPV drones in warfare. The increased autonomy and precision of these drones raise important questions about the rules of engagement, accountability, and the potential for unintended consequences. Ensuring that AI-driven systems are used responsibly and ethically will be a critical consideration for military forces and policymakers. The integration of AI into FPV drones has transformed them from recreational gadgets into powerful tools of modern warfare. AI has enhanced their flight control, target detection, and mission planning capabilities, making them highly effective in tactical operations. As technology continues to evolve, AI will further improve the capabilities of FPV drones, enabling greater autonomy, swarm operations, and integration with other technologies. However, with these advancements come important ethical and strategic considerations that must be addressed to ensure the responsible use of this technology. As military forces around the world continue to explore and leverage the potential of AI-enhanced FPV drones, their impact on the future of warfare will undoubtedly be profound. Please like and subscribe to my channel for more to come.